Please welcome Vice President, Serverless, AWS, David Richardson.
Hello. Thanks for joining us at re:Invent this week. With serverless, I like to start out a little bit with our mental model, how we think about things. And overall, our goal is to be the fastest way you can build your ideas into applications, while at the same time having the lowest cost of ownership over the whole lifespan of your application. And so we go about approaching this with some guiding tenets or some core themes that are areas that we're always working on every year. They start with agility. We want to help developers and operators be able to move fast and adjust to things happening in their business. Performance. We're always working to expand the performance coverage so you can support more and more workloads with serverless. We want to provide low costs, always improving costs, and ensuring they really follow the way you use the systems. And then really job one is security. It's built in, it's continuously improving, and wherever possible, we take on more of that shared responsibility burden. So when we talk about agility, if you've been to re:Invent before, you've probably heard us say speed matters in business. Whether you're a brand new startup, you're working on a college project, you're a 100-year-old enterprise, or a many hundreds-of-year-old university or government, there are always times when you need to be able to see what's happening and react. And so we try to build in the ability for you to get started quickly, focusing as much as possible just on your business logic, not on code to make the application run. And then we want to build in as much maintenance as possible so you don't get bogged down in things like scaling, security updates, and other maintenance. You can just focus on iterating. We want to make it easy to use the things that you already have. So we have built-in capabilities that make it easy to integrate across AWS to many AWS services and to your own applications. And then finally, wherever we can, we try to just innovate silently so that you get benefits without having to do work. Now, I don't know about you, but yesterday morning was my first flight since I flew home from re:Invent in 2019. And until a meeting of about 30 or so of us this past summer, I hadn't been with more than 4 or 5 people. So this is a strange experience seeing all of you here, let alone wandering the halls. But one thing that has really excited and motivated the team throughout the last 2 years is seeing where our customers have been able to successfully react and adapt to the pandemic using serverless. So I wanted to mention a couple. First is Neiman Marcus, who, as you probably know, has an amazing reputation for great customer service. And so when the pandemic forced many retail stores to close, their customers' sales moved exclusively online. And so they wanted to continue to provide that great customer experience. So they built a new Neiman Marcus Connect app, and they were able to do it in 2 months, basically twice as fast as the original 4 months they had estimated, using a serverless architecture. So Taco Bell has over 7,000 restaurants in the US and serves over 42 million customers every week. And they had to rapidly shift to meet consumer demand for online delivery during the pandemic. So what they did is they revamped their brand-owned loyalty program, and they paired it up with new digital channels to meet customer demand for delivery. And it's been so successful, they forecast that over 50% of delivery in the future will continue to be digital and online. So last year, when we were remote, I spent most of the talk talking about things that we're doing to enable enterprises and large teams to adopt serverless. So this year, I thought I'd start out by focusing a little bit more on what we're doing to help individual developers or small teams be more agile. So we think of AWS and Lambda as the pioneers in serverless, although really I should say it's you all that are the pioneers. Starting with our amazing serverless heroes, the incredible community that helps so many customers, new and old, big and small, learn how to build with serverless, and our whole range of customers are figuring out ways to be able to harness the cloud and move incredibly fast. So it's more like we're running to keep up with you. So ever since we launched Lambda GA in 2015, we've worked on as many things as possible to make it easier to build. So we've increased the timeout to 15-minute functions in 2018. We added provision concurrency in 2019. Last year, we added support so you can define your images in a container. You can define your functions in a container image. And all throughout this time, we've been expanding the set of languages and shrinking the latency. But as you saw, it's not just Lambda. We know that a typical serverless application actually combines a lot of services together. Might be Kinesis, could be API Gateway, SQS, all systems working together, following what I think of as kind of the core architecture principle of the web. Tim O'Reilly is the first one who spoke about it that I heard of. Small pieces loosely joined. And so one of our top priorities is to make it easier to build in these kinds of ways. So that's another place we're always working. OK, it's been a little while. Does anybody else find the squirrel a little scary? He's just so darn happy. I kind of think of him as like a Bond villain. Like, no, Mr. Richardson, I expect you to template. But kind of in a squirrel, chi kind of voice. I don't know, he scares me. So a thing about hooking these kinds of systems together that does concern our customers is that sort of core developer sitting in front of a keyboard, writing code, edit, dev, test loop, where you're really trying to work as fast as possible and get feedback. And so we've had countless conversations both inside the team and with customers that start out with, I'd really like to be able to run all of the cloud on my laptop. And I really want all the features you bring to the cloud to run on my laptop. And I've spent 20 years trying to figure out how to do that. Personally, I don't think it's possible. Come and find me. We'll have some coffee if you have an idea. I'd love to be proved wrong. But that doesn't change the need for that tight feedback loop. We really want to make it so that you can have the latency experience, the iterative experience of building in the cloud while working on your laptop. And so earlier this year, we launched SAM Accelerate, which is a set of capabilities that are intended to help you rapidly integrate with the cloud by building only the parts of your code that have changed, and then quickly syncing that up into the cloud, and then making it easy to see the logs that tell you what's happening in your application. So to give you a demo of that, I'd like to invite Talia Nasi, Senior Developer Advocate with AWS Serverless, to the stage.
Hi, my name is Talia Nasi. I'm a Senior Developer Advocate here at AWS Serverless. Today I'm going to demo SAM Accelerate to show you how much faster it makes serverless development. SAM Accelerate speeds up development by allowing you to quickly and iteratively test your changes against the cloud while you're building your application. There's 3 new features of SAM Accelerate that we're going to talk about today: incremental builds, SAM Sync, and aggregated feedback. SAM Build can now incrementally build your application, which saves you development time. So for this project, I have all of my dependencies saved in a manifest file. So the first time that I run SAM Build, it's going to build everything because there's nothing in the cache. The second time that I run SAM Build, it's only going to do a code update because I didn't make any changes to my dependencies. If I go back and I update my Lambda function and I rerun SAM Build, then it's going to do an incremental build because I didn't make any changes to my dependencies. However, if I go back and I update my manifest file, if I add or remove any dependencies, and I rerun SAM Build, then it's going to do a full build as opposed to an incremental build. SAM Sync is a new feature that synchronizes infrastructure and code to the cloud in the most expedient way. The first time you run SAM Sync, it'll do a full synchronization of your infrastructure to the cloud. Now, in order to really understand SAM Sync, we need to differentiate between configuration and code. Code is defined as anything in your Lambda function code, your Lambda layers code, your OpenAPI specifications file, and your step functions Amazon States language file. Everything else is considered configuration. When you run SAM Sync --watch, SAM automatically watches for changes in your project and syncs up either all of your infrastructure changes or just your code changes. In this SAM template, I've defined a Lambda function, an API Gateway API, and a step functions state machine. Note that in order for SAM Accelerate to work with step functions, you need to define your state machine in a separate Amazon States language file. I've also set up logging with CloudWatch logs. Now I can see that SAM sync has completed, and we have a URL that we can use to test. So let's go ahead and curl that endpoint and make sure we get a response from our Lambda function. Hello world, welcome to reInvent, great. Now let's run SAM logs to see the logs for that invocation. And I'm going to tail this so that I just see logs from the past minute. So now every time I curl this endpoint, I'll be able to see the logs for that invocation. Now I also want to verify that the code in the cloud is in sync with my local development environment. So to test that, I'm going to go back and I'm going to update my Lambda function. Let's add great to see you. As soon as I save this, SAM sync is going to pick up that change, almost instantaneously syncing that. Now let's verify that that worked, and we can see that update, and you can see that great to see you there. And if I look at the logs, I'll be able to see the logs for that invocation. Now I also want to take a look at how SAM sync works with state machines. Right now, our state machine just outputs some metadata, and we'll see that metadata coming in. There it is. So right now we have some metadata. I'm going to update our state machine so that it invokes the Lambda function we previously created to show how SAM sync updates state machines in the cloud in real time. Now, our state machine was also wired to push logs to a CloudWatch logs group. This is so that we can get aggregated feedback with SAM logs. So previously, you only received CloudWatch logs for your Lambda functions. Now you receive logs from your Lambda functions, your step function state machines, and your API gateways that are declared in your stack with aggregated feedback. So now I can see in SAM logs, I'll be able to see the logs from all of those different services. This is why SAM Accelerate is so powerful. It allows you to test your changes as you're going, and you don't have to wait for long deploy times. Now, another thing that I can do if I also wanted to get traces with AWS X-Ray, I can add include traces to my SAM logs command, and I'll be able to see traces with AWS X-Ray. And if I only wanted to see traces for X-Ray, then I can just run SAM traces, and I can see only the traces from X-Ray. SAM Accelerate is a powerful feature of the SAM CLI that greatly speeds up serverless development. Try it out today.
Thanks, Talia. So I hope you'll try out SAM Accelerate. You know, we're actively working on it. We'd love your feedback, so try it out. Let us know. Let us know what else we can do to help speed up development. So we think of SAM, or the serverless application model, really as a family of capabilities. It started with, and for many customers, continues to mostly be the core of being able to model the interaction of multiple systems together and use the SAM transform. But we're also continuing to iterate and invest in the SAM CLI, which is really a set of tools and umbrella around things like SAM Accelerate. And another thing that we launched earlier this year is SAM Pipelines. You know, in the spirit of, there's just some critical stuff that you have to do to be able to be efficient in the cloud, but that's not special to your business. Having great CI/CD pipelines ranks right up there. Inside of Amazon, I lost track once we reached millions of deployments a day. You know, and you couldn't do things like that without a really rich, complicated CI/CD system. And managing these things can be a chore, especially for standard applications. So we've added the ability to SAM to be able to build standard pipelines for you and manage them. using the templates that model your application, and then integrating with popular CI/CD systems. So we hope you'll try out that as well. So those things were probably pretty typical of what you might expect we would do to help developers be more agile. I'm going to take a couple minutes to try to convince you that developers, that engineers, engineering managers should also think a lot about costs. And we'll see how successful I am at that. I've been a little bit nostalgic this year. This is my 15th year at Amazon. I joined in January 2006. And almost from the start, I've been working with AWS. I joined our infrastructure group, where my first job in the first week was to get the compute and networking and storage capacity that these not yet launched services, later called S3 and EC2, needed to get launched. So I spent the first part of the year on that. I have to admit, it was not my favorite job ever. And later that summer, the VP of infrastructure, Tom, asked somebody to write a proposal to build a content distribution network. Well, I didn't know what a CDN was. I didn't know how AWS wrote proposals. I'd never even written a business plan, but I needed to do something different, so I raised my hand and volunteered to do that. I have no idea why he said yes, but I spent the next couple months building up a business plan, and like anybody who doesn't know how to do something, I Googled business plan, and one of the core elements was a budget. I thought, well, I can balance my checkbook. How hard can it be to make a budget? So I set about trying to budget what it would cost to build and run a CDN, or content distribution network. And so it starts with infrastructure. And of course, you start with the obvious thing, like how many servers you'll need. You make kind of some estimate of, for a CDN, it's more about the bytes served per second per server. Maybe for some other applications, the requests served per second per server. But start with servers. But you also need data center space. And for something like a CDN, that's ridiculously expensive. It's these things called carrier hotels. Sort of think like Manhattan near Central Park real estate prices, or for my team, Vancouver, British Columbia. Really expensive. And you also need routers and switches because you have to run a network. And usually you also need things like operations hosts and security systems. Like as I was building out this plan, I got to talking with Amazon's physical security, and they said, well, yeah, our usual footprint is we need 3 racks worth of equipment that we use to monitor the physical security of a data center. And I thought, in my budget, I can only afford 5 racks. So there's no way on earth that we're going to be able to dedicate 3 of them to physical security. So I knew we had to do some innovation there. And then even after you've thought about all of that, you have to think about supply chain. And especially in a time like this, you realize, well, supply chains can get long. And so you have to have enough capacity to serve customer need relative to how long it takes to replenish your capacity. So I started out with a simple model of infrastructure. But then you realize, well, you kind of also have to plan for problems because nobody's lucky enough to have perfect luck all the time. So you have to plan for things like losing a server because the motherboard gets fried, or losing a whole rack because maybe the power supply for the rack went down, or even losing multiple data centers because maybe your main internet carrier has had a regional outage. So there are lots of ways that you can lose physical infrastructure, and you have to budget for that. You also have your own software failures, or your need to be able to deploy software, so you have to plan for that. And then once you're at that level, you realize, oh, it's not enough just to have kind of spare capacity. I now have to have capacity that lets me route around failures, and that takes up capacity and engineering needs and so on. And so usually that's a load balancer. Now at the time, Amazon was addicted to hardware load balancers. We used them everywhere. And as I started to build out the budget, I realized, well, if I went with a typical Amazon architecture, that would be 30% of my cost structure, which is huge. And I thought, I don't know. So let me come back to that. OK, so we've got core infrastructure, we've got resilient infrastructure, and then there's utilization. And I think of it as the black hole of optimism. It's where everybody eventually runs into, oh, it's a lot worse than I thought. You can search the web for all kinds of studies about typical enterprise CPU utilization. It's usually around 10%, maybe rarely 20%. But that's not always measured in a business realistic way. You have to plan for a peak to average ratio. Typical studies will tell you the internet has about 2 times peak in the US. It's usually the East Coast, kind of 9 to 10 a.m. on a Monday, relative to the average. But if you're a young and fast-growing business where you want to be able to keep winning bigger and bigger customers, that next customer may drive your peak to average ratio to 10 to 1. Or if you get really lucky, 100 to 1. And you don't want to have to say no to that customer that you just worked hard to win. So you kind of also have to plan for your utilization to start terrible and then maybe improve over the years as you both have a smoother customer base and you've been able to invest in it. So those 3 things together made up the core of the infrastructure bill in my business plan. So then I had to think about software development and how to staff that and what that would look like. And here's where I started to use the budget I had built to say, oh, I have this amazing junior engineer who really loves a hard challenge. What if I challenge him to invent a way out of needing a hardware load balancer? Now I had, at the time, a senior principal engineer tell me I was crazy and it would never work, so that wasn't an easy bet, but that's okay, I'm willing to take some risks. So we set the team up to do that, thinking about how development can radically change our cost structure. But development isn't just development. You have all kinds of maintenance things around the raw act of building and modeling your software out through deploying it. And through the time I had spent supporting EC2 and S3, I saw 2 very different models. S3 had chosen to use a lot of Amazon's internal software development tools and got quite a bit of productivity out of that. For good reasons, EC2 wasn't able to do that. So they had to invest a lot of engineering effort just into building tools. And so, seeing this, I again sort of structured my plan so that I think in all about 150 different teams across Amazon had to make tiny little changes so we could use their tools, but that really paid off. So I submitted the plan. I just went and looked it up because I was curious. In October of 2006, so 15 years ago last month, we kind of said, interesting, put it on hold for a year. And then in January 2008, I got the green light, go start. And with initially about 6 people, we were at 10 people. We started taking customers in 10 months. So we were really able to run fast. And having built out that budget was super helpful. I have to admit, it was super helpful for me professionally as well. Really changed my professional life, and super appreciative to the people who supported me in doing that. Anyhow, the reason I mention that story is when I talk with customers about understanding the costs of serverless applications compared to traditional, I see a lot of similar misconceptions. Many times a customer will compare the cost of an on-premise server without knowing anything about the physical data center or data tax or physical security surrounding that. Or they may look at the price of a 3-year RI reserved instance that they assume they're running at full utilization compared to a raw Lambda gigabyte per second, which isn't really a fair comparison. They forget that Lambda has a built-in load balancer. And Lambda has built-in resiliency. It has already pre-provisioned capacity around multiple AZs, so you don't have to build AZ resilience in yourself. And they may forget about maintenance things, like, well, you need to be able to deploy software. So whether you're using blue-green or some other strategy, usually that's extra capacity during deployment. And you may also want to be able to have a pre-production stack, so you can test your software as part of a CI/CD pipeline before rolling it out. Or you might want your developers to have stacks. So you can quickly see that the amount of infrastructure required can really add up to match all of the practices that are built in to Lambda. On utilization, even these graphs are wildly optimistic, but it can be really hard to be able to drive things at high utilization. If you're on premise, you have to think about your supply chain, which can easily be 6 to 8 weeks in the best of times, can be significantly longer in other times. So you have to have the capacity to support all of that. It also can take, however long to activate a new server. If you're building with VMs, maybe your supply chain's much more elastic, and it can take minutes to spin up. So you can start to fine-tune your utilization closer to your workload. With containers, maybe that minutes shrinks down to tens of seconds, whereas with Lambda, it shrinks down to tens to hundreds of milliseconds. So you're really able to have much tighter utilization. And this is just about compute. If you look at things like messaging or eventing, those are pure pay-per-use. So that's a little bit about how to compare the infrastructure costs when you're looking at budgets. Then when you think about development and maintenance, you have to think about, well, what all is your team responsible for? If your team has to build capabilities to manage a lot of infrastructure, well, you need people for that. And we all know the larger a team, the more of their time and energy that has to go into just coordinating, to communicating, so that they're all on the same page. So you wind up having more and more of your team's time go not into delivering the direct business value, but into managing the fact that it's a larger team. So where we see customers be able to be successful with very small teams leveraging serverless, they also find that a larger percentage of their time just goes into building. Now, we also try wherever we can to build in as many capabilities as possible, and especially integrations that make it easy to use things that you've already built. And that kind of fits this pattern where many serverless architectures are a little bit of a remix, reuse, where it's a combination of new capabilities integrating with existing systems. And then, of course, ongoing maintenance. So some things that we're trying to do to lower your costs that fit in the spirit of all of this. Last year, we reduced the billing granularity for Lambda down from 100 milliseconds to 1 millisecond. So if you imagine back at that graph, now when you compare your utilization on an instance or an on-premise, you have to compare it on a millisecond by millisecond basis, not by days. And for some customers, this shrunk their bill by up to 70%. Just on Friday, right before reInvent, we launched another ability, which is for you, with a little bit of configuration work, to pre-filter all of the events that feed your Lambda event mappings. So let me explain that a little bit. Up until now, whenever you configured event mappings, probably a common thing that you had to write in your Lambda business logic was, do I actually care about this bit of data that triggered a Lambda function? Should I exit or should I continue? Or if you built a system like that on premise, you had to scale up a filtering and matching system. So what we've now done is made it so if you go and you update your event mappings with this filtering, we'll process and drop on the floor any event that doesn't need to be processed by your Lambda function. So that shrinks your scaling down. It reduces your Lambda functions to only processing events that you care about. And again, we've seen for some customers up to a 70% savings. So 1 millisecond billing, no work at all. It just happened. This one takes a little bit of work. And then earlier this year, we made it possible for you to recompile your functions to run on Graviton or Graviton 2, passing on the same kind of price performance benefit that we've seen on lots of workloads that have moved to Graviton across AWS. So here requires you to recompile, but with the growing ARM ecosystem, that's becoming easier and easier all the time. So as I mentioned, the thing that excites our team is hearing about customer successes. And in the topic of reducing costs and having great TCO, there's no customer that excites us more than hearing about Toyota, the Toyota, the Toyota lean manufacturing process. And so Adam mentioned in his keynote their change to become more and more a mobility services company and having connected cars. And a big part of the Toyota connected system was they built a Toyota mobility services platform that uses AWS and is built with serverless to be able to bring those services to customers. And they found that this increased their agility, their flexibility to scale, and lowered their TCO by 70 to 80%. So we're really happy to hear about that. Now, if you have school-age kids, over the last 2 years, there's a good chance you've seen the shift to online K-12 education. PowerSchool delivers a grading and performance analytics system that starts by scanning tests and schoolwork. And it's critical to many schools. And so last year in April, they migrated to a serverless architecture using Lambda. Despite the growth in their business that you could imagine, their cost shrunk from about $15,000 a month in their own data centers down to $200 a month with Lambda. And at the same time, their performance improved at high percentiles, down from 30 seconds in their original architecture to less than 12 seconds with Lambda. So we love it when customers are able to reduce their TCO. So our overall model is that you only have to pay for what you use. We try to make it so you can write less code, use the built-in capabilities rather than having to write those yourself, and spend a lot less of your engineering time on maintenance. And that one in particular is worth kind of thinking about. For all but the largest applications, most customers find that actually their engineering costs are far higher than their infrastructure costs. And for a typical long-lived application, you can easily spend 80% of your staff costs on maintenance and only 20% on initial development. So we think that's a big benefit. OK, so I can't guarantee that you'll have as career-changing event as I did if you dig into budgets, but I really encourage you to do that. So let's talk a little bit about how customers go about building applications. So we often see a pattern when customers are getting started. They'll often start out with IT automation, hooking some events up from, say, some parts of their AWS system into an event bus or into Lambda. They'll then, as they become comfortable with it, start to move to data processing. They'll do jobs that involve either data streaming or intensive data workloads like ETL. And then they'll move into core compute, such as microservices. So again, this architecture pattern of small pieces loosely joined. They all have in common the idea that you have some systems, some that are existing, some that you may get from your cloud provider, some that you're writing anew, that you want to bring together to solve a business opportunity. And I think what's interesting about all of them is more and more they are becoming asynchronous. And I really think that design pattern is the natural way to build evolving and reactive applications. And there's a long arc of history of this in our industry. I think the kernel development people actually were some of the earliest, especially as multi-core became so common and the cost of stalling a core became critical to really embrace asynchrony. But it also is an embraced recent trend. I think first with Golang, and then with JavaScript, and most recently with Swift, we're seeing very popular programming languages build right in the capability to do asynchronous programming. And so I think that architectural pattern fits really well with serverless applications. So as I mentioned, data processing is kind of one of the core use cases for many customers with serverless. And it's because it's just a good fit. You have a natural composition of some set of data in your environment that may be flowing through or may become present that you want to react to, that you want to do some computation or you want to trigger off something else. And so we've worked hard over the years to make it easy to couple things like Lambda with Kinesis and with Managed Kafka and with DynamoDB streams. And one thing that's been interesting is the expansion of that workload, especially into machine learning. And so last year, we launched the ability to have, with container image functions, very large package sizes to support big models. We also launched the ability to have your Lambda functions work well with EFS to work on large data sets. And so I wanted to pre-announce something that we'll be launching early next year, which is the ability to provision ephemeral storage to go along with your Lambda function. So you will be able to provision up to 10 gigabytes of ephemeral storage. You'll pay for what you provision. And we think that most customers will use it for running data-intensive or machine learning type workloads. I have to admit, the diversity of our customers and the diversity of their ML workloads has really surprised me, and it's been fun to watch. So one that's interesting is Wiley Weather, and they organize the world's weather data into the most valuable information that's local to their customers. So they reach over 5 million customers in Australia, the US, and the UK, and they can scale up in real time when there are severe weather events. As a different type of customer, Asurion, who provides insurance, especially for devices, they use Lambda and EFS to perform real-time analysis of their customers' experience during support calls using ML models. And they were able to scale elastically with their customer case volume, and they reduced their overall operational overhead compared to traditional architectures, which has helped them move fast. Okay, so in addition to data streaming, across a broad array of workload types, a lot of how customers benefit from serverless is using built-in service-to-service integration, again, to support that small pieces loosely joined. And it's not limited just to Lambda. We've done a lot of work over the last year or two to reduce the times that you need to write just a tiny little bit of Lambda glue to kind of get between point A and point Z. We want to make it easy for you to just glue two random services together if that's what best meets your need. And so some good examples of that were earlier we added the ability for API Gateway to trigger synchronous express workflows in step functions, not only directly, but then also to receive a response that can be translated from step functions into an API response. We've been doing a lot with step functions. And one of the big changes is we've made it so that now step functions can integrate with EventBridge by generating events. And that helps you decouple the parts of your application that should be orchestration-oriented from other parts that might want to be event-oriented. We've also expanded the integrations that step functions supports. Up until recently, it could support about 17 AWS services and 46 of their APIs. We've now integrated with the SDK in a way that you can get integration with over 200 services and over 9,000 APIs. And this is important because in this small pieces loosely joined architecture, sometimes you have to do a lot of joining. And that can just be a lot of work. It's powerful, but it can take a lot of work. Starting down at the lowest level, just simple things like back off and retry logic. And I can't tell you how much time inside of AWS we've put into just what seems like should be simple. Like, I want to call you, you weren't ready. Okay, I'll back off. Try again. Back off, retry, receive queues. Tuning all of that is critical, but undifferentiated. And so being able to use step functions to handle those low levels is sort of the minimum bar. But I think even more interesting is being able to express some of your business logic in a workflow. And that really can reduce the amount of code that you have to write. And that's where managed workflows can be very helpful. So I have to admit, I'm maybe a little strange. I like state machines. This drawing, which is the TCP state machine, is one of my favorite drawings. And it comes out of one of my all-time favorite books, W. Richard Stevens' TCP IP Illustrated Volume 1. So some other day, when we're debating if you can run the cloud on your laptop, I'll tell you when I first started using the internet. But when I read his book in the early 90s, it was a real epiphany, both about literally how the internet works, but also just how to be an engineer. It's an amazing book that really starts to teach some mental models of understanding a situation, a context, looking at a series of proposals of how to try to solve that, really looking at how different aspects of a solution came to be, mixing in a little bit of history, and of course, because we're engineers, a lot of broken stuff, and showing how it got broken, in some cases the stories and even the people behind the breakage. I think I've read that book cover to cover 2 to 3 times, and there were several years where I looked something up in one of his first 3 volumes probably almost every week. We actually had an operational event a few months ago, and I realized I'd left my copy in the office, so I had to search the internet because I wanted to look up the TCP state machine. So I went back into the office last week, and I found the only bookmark in there is the TCP state machine. So I love this. I'd encourage you to go read the book as just a beautiful examination of engineering. But part of what's so powerful about state machines is they're incredibly information dense. If you just spend a little time sort of mulling through that, you can really understand in a very dense way the dynamics of a very complicated system. Now, on the other hand, I know not everybody likes state machines, or at least not programming them at a textual level like in the Amazon States language that powers step functions. So we wanted to make that simpler, and we've now launched a visual experience for building and interacting and inspecting step functions state machines, or step functions workflows. So we've launched AWS Step Functions Workflow Studio, and I'd like to invite Talia back to the stage to give you a demo.
Hello, hello. Great to see you all again. Have you lost weight? All right, so I'm really excited to show you this new feature called the Step Functions Workflow Studio. Developers can now build serverless workflows in AWS through a new visual experience called the Step Functions Workflow Studio. It makes it easier and more intuitive to build serverless applications by empowering developers to focus on their business logic as opposed to writing configuration code or workflow definitions. To get started with the Workflow Studio, head over to the Step Functions console and choose Create State Machine. Then choose to design your workflow visually, and on the next screen, you'll be taken to the Workflow Studio. Cue the fireworks. The Workflow Studio is split up into 3 different sections. On the left is where you can search and browse for different actions that you'd like to add into your workflow. You can do things like invoke a Lambda function, put an item into a DynamoDB table, or get an object from an S3 bucket. There are over 200 AWS services to choose from and more than 9,000 APIs. You can also configure the flow of the actions. You can run things in parallel. You can add if-else logic. You can add waits between things. In the middle is where you drag and drop the actions to build your workflow. And on the right is where you configure your workflow. So you can configure all of your actions from the right panel. You can add input and output path processing. You can add error handling. You can add timeouts. So for this demo, I'm going to build a serverless workflow that does sentiment analysis. So the first thing I'm going to do is I'm going to search for the detect sentiment action from Amazon Comprehend. I'm going to drag that into my workflow. Now I can configure this action by editing the API parameters. I can change the name of the state. I can choose the next state in the workflow. I can also choose a fallback state if errors occur. I can add a timeout for this state. Now, if Amazon Comprehend detects negative sentiment, I want it to send a notification with Amazon SNS. So what I'm going to do now is I'm going to choose the choice state. And the choice state allows me to set conditions to the output of the previous path. So now I'm going to choose rules, and then choose condition to add a new condition. And this is going to check that the input is equal to a string constant of negative. So that means that there was negative text detected. If there was no negative text detected, then the workflow will pass. So I'm going to add a pass option, the pass state as the second option. Now I need to add an action from Amazon SNS so that it publishes to a topic whenever there is negative sentiment detected. Now at any time, I can choose the definition button, and that'll show me a JSON of my entire workflow. I can also copy this by choosing the copy button. Now, the cherry on top of this cake is that once I'm done building my workflow, Step Functions will automatically detect which permissions I need based on the actions I added. So here it's detected that I need a permission called detect sentiment. On the next screen I'll be taken to, I can edit this role directly in IAM. The IAM integration with Step Functions makes it easier to follow the principle of least privilege. You only want to give your steps and your services the permissions needed to do their job. So I'm going to search for the service I need, Amazon Comprehend. And then I'm going to search for the action, detect sentiment. On the next screen, I'll be able to give the policy a name. And then I can attach it to my workflow. At any time, I can go back and I can edit my workflow, and I can continue to drag and drop actions as I need based on my requirements. The Step Functions Workflow Studio is a powerful tool for building step functions workflows in AWS. There's over 200 AWS services to choose from and more than 9,000 APIs. This is just another way we're making serverless development easier and faster.
What do we do here? Thanks, Talia. Any new state machine lovers? Oh, come on. OK. So the other main architecture pattern that customers often use are event-driven architectures. And I'd actually say this is the most popular pattern, the most common, because it's really about how systems and businesses and the world talks to each other. In many ways, I think of this as the Back to the Future pattern, dating back to popular enterprise message bus patterns of the late 80s and 90s. And those same event-driven architectures are relevant today because they're ideal for agility. They lead to loose coupling, and they're a natural pattern for how one system can react to changes in another, or get another system to react to changes in it. And they also provide great support for building new capabilities or refactoring existing systems. So it's really, the way that one part of a business can say something happened and the rest can react to it. It actually was the original idea that led to Lambda, that something happens in one of your S3 buckets and you want to do a little computation on it. And we expanded that with EventBridge, so that now virtually every AWS service, but also your own custom events, and also events from popular SaaS applications can be put on the bus. And then you can trigger things in a wide array of other AWS systems with Lambda, which is a common one. And now with the addition of API destinations, you can also trigger activity in popular SaaS systems, in API Gateway, and pretty much anything that looks like a webhook. And part of what's great about this is it can allow you to make and evolve very adaptable systems. And so you may build out a new capability that starts with API Gateway and supports a new customer experience that then can have step functions, trigger a set of back office workflows that might check an inventory service, use a fulfillment service, and then update the books. And those inventory or fulfillment or accounting systems could be things that you've had for years. They could even be decades-old systems that run on a mainframe, or they could be things that you're evolving that used to run on a mainframe, but that you've now replaced with a Lambda function. That's the beauty of events, that all of that implementation is hidden behind, and you just have to know what events you want to emit and you want to consume. So we have a great customer, Mathem, who built using EventBridge. So they are Sweden's largest online-only grocer, and they started using Lambda in 2017. As the pandemic started in March 2020, though, they saw a huge surge in customer demand almost overnight, over 800% day over day. And while their applications were able to handle this load, they scaled up just fine. They didn't have enough delivery capacity, and they ran out of delivery appointments within minutes, appointments that used to last for days, or for the whole day. So to avoid disappointing customers, in just 3 days, they were able to build a new event-driven architecture with EventBridge that allowed customers to actually change the workflow. So they started out first reserving a delivery slot, and then after that, they added groceries to their cart. So our goal is to provide a wide array of event sources. We have over 180 AWS services. It's possible to generate and receive events in your applications with third-party applications like SaaS. And you're able to use these to combine and mix and match in whatever way your applications need to evolve. So that's a little bit about how we think about serverless helping you be agile. We're trying to always build in new capabilities that help you move fast, especially as a developer with things like SAM Accelerate and AWS Step Functions Studio Workflow, or Workflow Studio. We're trying to expand the range of performance that we support so you can have more and more applications that can be built in a serverless way. We continue to try to bring down your costs, both directly through things like 1 millisecond billing and allowing you to run Lambda functions on Graviton. And we're constantly iterating on security, building as much of that in as possible so you don't have to take care of things like patching and keeping runtimes up to date. So I wanted to thank you and our amazing group of customers for the ways that you've challenged us, for the ways you've given us ideas to be able to help you out, and especially for sharing your successes with us. So I hope that you'll leave here, you'll go build, you'll let us know what we can do to help out, and thank you very much.